Hello students, welcome to this lecture. So in this video we are going to see about the timers and counting devices. So in embedded systems, timers and counting devices are very much important. That wherever we need to have the timer related and the counter related activities, we need to have that timer devices or the timer internal circuitries for dealing with those kind of applications. Most of the microcontrollers have their own modules of timers. They can be configured at a very wide range of modes and counting applications. So depending upon the applications and way of approach, these timers can be classified into many groups. So we are going to briefly discuss about those type of groups and those type of configurations in this particular video. So before going into those details, we will be discussing about the what are the differences and what are the basic configurations of a timer and the counting devices. So normally timers are mainly the inbuilt part of any microcontroller or microprocessor. In microcontrollers there will be dedicated timer for applications, but in microprocessors there will be dedicated timer for any application. But they will be having internal oscillators. Those oscillators are supplying clock frequencies to the applications. So those clock frequencies are going to be taken as a ticks, that is a system ticks. So based upon the frequency of those applications, that system ticks, the clock frequency will be taken, and the internal clock and the all the timing control of those microprocessors will be dealt. But in microcontrollers, the division of the particular timing pulses will be done using some of the inbuilt circuitries that we will be discussing in the upcoming slides too. So by dividing those particular timer pulses, we will be using those timer pulses for various applications like serial communication, PWM generation, and the ADC generation, DAC conversion. So those kind of applications can be controlled by those timer modules. So what are the basic differences between the timer and counting devices is mentioned here. The timer device is a device which counts the regular interval clock pulses. That is, that particular clock pulses will be having the time period of del t at its input. So we will be given an input. That particular input will be a regular time interval clock pulses. So we will be having the square pulses which are having the on period of del t. So those kind of square pulses are going to be the inputs for the timer devices. Based upon those inputs, the timer devices will be working. So upon giving these inputs, so upon reception of the either rising pulse or trailing pulse, we will be having those particular pulses as an input, and we will be counting those values up to one preset value. So the maximum preset value will be given to the timer. So based upon the value of the preset, the timer will be upcounting. So upon upcounting of those particular pulses, upon reaching that particular preset value, we will be given an interrupt. So based upon the interrupt request, we will be doing other duties which are assigned to that particular timer. So all the timer circuits will be having that input. That is, that particular input will be supplied by the internal oscillator of microprocessor or microcontroller or any timer chips. It has a reset pin. So in order to on the overflow, in order to having the timer to restart, we will be needing that reset pin, and the output pins can have zero output when the timer overflows. So this is going to be a common thing, that is output pin will be having the output as 0. So whenever it is given 1, the timer will be restarted, and the reset pin will also be given 1. So by that time the timer will be restarted and it will be getting into run up to the maximum count which is set on that particular timer. So how to find out the time period of a timer is called as the count value. So it can be calculated from the count value, that is the value which has been given in the timer control register. So that timer control register will be given the maximum count. So that maximum count into the particular del T value which is given as an input from the oscillator circuit. So if you multiply these two values, then we will be calculating what is the maximum amount of time period that can be attained for that particular given count on the preset as a preset value to the timer. So the interval between two instances can also be calculated, that we will be giving that particular maximum count, and we will be having the initial count, because the timers are going to be updating at the every instant of times. So the value of the initial count will be always be 0. So the count minus the initial count into particular del T value will be giving the interval between the two instances. So this particular interval between two instances can be applicable to this particular counting device also. So we will be seeing what is the meaning of the counting device. So counting device is a device that counts the input for events that may be regular or irregular intervals. That is, we may be having regular or irregular intervals. So those intervals are the inputs to the inputs for the event. So that can be counted by the counting devices. But in the timer, we will be only having the regular type of interval clock pulses, but here we may be having irregular intervals too, because the counter devices may be dealing with regular or irregular type of applications. So those applications can be met out by this counting devices. So count gives the value since it was last read. That is, the count value can be updated each and every time whenever we are reaching that maximum value. So upon reaching that maximum value also, upon overflow also, we can update those particular values into the maximum amount of counts, so that we can read those values and from the updation of the last reading also. So the counting devices are going to be a free running timer with the prescalers. So we will be having that particular oscillator circuit as a free running oscillator. So that particular free running oscillator will be giving the clock pulses. That clock pulses can be divided by the some prescaler values. So those prescaler values may be 1, 2, 4, 8, 16 and 32 and so on. So these prescaler values will be given as an input for the division. So upon the division, we will be having the resultant clock pulse. So that clock pulse will be given as an input for the counting devices. So upon reception of that particular clock pulse, the del T time will be varied. So depending on the del T time and the count value, we can find out the clock time period also. So the clocks divides this. So this particular point will be giving that particular detail. So the counter divides the clock by prescaler value and starts counting using the resultant. The counter value is loaded into the compare register. So this particular counter value will be loaded into that compare register. So when the control bit is set, the output is ready. So the interrupt generated by that particular reception of that particular value. So upon reception of that value, we will be generated with the interrupt on the output pin unequality of the compare with the count. So this is the main work which has been done using the compare register. So we will be given with a compare register. So in some of the microcontrollers we will be having the compare register and compare module also. So for DSP processors also there will be inbuilt a dedicated timer and dedicated compare register for generating PWM pulses and for control clock pulses for the ADCs also. So in most of the DSP processors which are coming under the category of real-time processing like TMS 320, C4X or 3X or 2X type of processors are coming under the real-time processing applications. So those kind of DSP processors having these kind of compare registers, and also they will be having capture registers also. So how to using that capture facilities are the main one of the main application of the counting devices. So there are some devices with the capturing facilities too. The working is same as we have defined for the compare register, but they have the additional input pin called capture. So for sensing an external event. So whenever we are being forced to listen to an external event, so that external event will be giving an irregular intervals of pulses. So we will be counting those pulses from our capture pin. So upon an occurrence of the high on that particular pin, we will be making that count, and the count value will be saved, and we will be generating the status bit upon reaching the maximum count. So the interrupt will be generated to the processor to capture that event. So whenever we are given irregular event of capture, so that event will be recorded upon reaching the capture value which has been given. So these kind of operations can be seen in the PIC microcontrollers also, and also in the DSP processors for capturing the external events for ADC control and the PWM control also. So next we will be seeing the main applications of timers. So as a first application we will be seeing as a real-time clock. In the real-time clock, this kind of real-time clocks are not going to be resetted at any mode, and they cannot be adjusted at any time. So whenever we have been starting that particular clock, the clock will be running continuously and they cannot be stopped and they cannot be reset. So the system ticks are being converted into clock timings. The clock which cannot be stopped and reset are going to be the real-time clock. So upon having that particular 60 seconds of input, clock pulse will be converted into 1 minute, and 60 minutes will be converted into hours, and so on. So we will be having that particular continuous counting of the clock pulses. So upon continuous counting of the clock pulses, we will be updating into years also. So some of the real-time clock ICs may be calculating the leap year also. So we can use those kind of real-time clocks in the embedded systems wherever we need that kind of controls. So the second one will be the initiation of the events after the preset delays. So the third one will be the initiation of event after comparison between preset and the count values. So these two kind of things we have seen in the previous slide also. So I will be shifting into the others. So capturing an event and the time of occurrence of an event. So this is also we have seen in the previous slide also. Finding the time interval between the two events. So this particular formula we have seen in the previous slide itself. So interval between the two instances, likewise we have seen. And waiting for the message in a queue or mailbox or semaphore for the predefined period in RTOS. So in real-time OS, whenever we are using those kind of real-time OS, we will be having some of the processors are going to be designed with the scenario of having to wait for one resource to be allocated from the microprocessor or the memory side. So upon waiting for that particular resource, that particular processors will be waiting in the queues or mailboxes or in the semaphores. So we will be giving some of the predefined period for those particular queues and the mailboxes, and that particular process will be waiting in those queues for receiving a message. So for a predefined period, that particular message will have to be received. So if that particular message is not being received, then that particular process will be shifted to the other, that process can be will be forced into sleep mode, or that process can be deleted also. So for those kind of operations, the RTOS will be needing this kind of timer applications. So this is one of the application in RTOS based on the timers. So next will be the watchdog timer. So about this particular watchdog timer, we will be seeing the separate video. In the next video, we will be seeing this particular timer in detail. So next will be the baud rate control for the serial communication. So the baud rate control for a serial communication is based upon the prescale value whichever we are giving. So based upon prescale value and the postscale values whichever we are tuning into that particular serial communication, upon tuning of the baud rate of that particular system, we will be giving that particular tuning for that particular timer. So this is going to be one of the great applications for serial communication purposes. And the next one will be the non-periodic input pulse counting. So this particular non-periodic input pulse counting will be coming under the category of counting devices. So all of the counting devices can be programmed to having this particular kind of applications. So next will be the scheduling of the events for RTOSs. So for the RTOS which are using the interrupts for scheduling of the events, so most of the RTOS having the schedulers, and they will be dealing with the separate algorithms for those kind of scheduling of the events. So upon scheduling, that particular scheduling algorithm will be scheduling that particular events, and upon scheduling of those events, the RTOS uses the interrupts for scheduling. So upon scheduling, it will be giving interrupt to that particular event, and that particular interrupt will be doing the work. Upon finishing of that particular work, the event will be giving an interrupt to the RTOS to do the next scheduling for the next events. So for those particular applications, this kind of timer devices can be used. And next will be the timing slices. So this will also be an RTOS application RTOS application itself. In this particular applications, we will be giving context switching between the events. So in most of the hard real-time operating systems or hard real-time systems, we will be having the preempting context switching between the events in order to finishing those events into the given time period. So for that, we will be giving time slice for a particular event. So between that time slice, that particular process have to be finished, and if it is not finished, then it will be forced into the waiting state. So upon the next time slice only, that particular process will be given time and the resources, so it have to be finished within that particular time period. So for the every events, the maximum time period will be given as 16.6 milliseconds for the all of the RTOSs which are using in our day-to-day life. So this particular type of time slicing may be implemented using the timers. So the next will be the time division multiplexing. So this time division multiplexing is very popular in case of the DTH systems which we are using in our day-to-day life in our house. So the time period for each and every channels will be allocated for to be visible for that particular user. So those kind of time division multiplexing can be done for all the embedded systems like we have seen in the day-to-day life of our DTH services which are given to our homes. The forms, the popular forms of timers are going to be hardware internal timers. So these are all the hardware timers which are internal to any of the microprocessors and microcontrollers. So after that we will be having the software timers, RTOS controlled hardware timer, because these kind of RTOS controlled hardware timers are very much needed for these applications whichever we have seen here. And timer with auto reload facilities that can be handled the timeout events. So auto reloading facilities are going to be used for most of the counter and the manufacturing units monitoring circuits. So those kind of timers are can be used in those type of timeout events. Next will be the one-shot timer. So the one-shot timer, when one event is finished, this timer will be started, and at the end of that particular event, the another event will be started. So for making that particular programming of that particular event's timing, so we will be having programming that particular timer into a one-shot timer. So upon starting of that particular event, we will be starting that particular timer, and upon ending that particular timer, we will be starting another event. So based upon the preset value whichever we are giving in that particular one-shot timer mode, that particular timer will be controlling that particular event to finish off that particular event. So the next will be the up count action timer, so and down count action timer. These are all the basic applications of any timer. The timer with overflow that can be auto reset, and the timer with overflow that do not need an auto reset. So these two kind of activities can be used for the auto reloading purpose also, and if any timer doesn't have that particular auto reload, they can also be used with that particular timer, with setting that particular timer don't have that particular auto reset mode. And the main states of the particular timer's operation has been listed here as we have discussed in this particular slides. So next will be the hardware timer. So here we have given one of the form of that particular timer as a hardware timer. So here it has been given the main basic functionalities of a hardware timer. So the hardware timer will be supplied with an internal clock process by internal oscillators of processors or controllers. That particular clock process will be given into the prescaler, as we have discussed in the previous slides, that prescalers can be 1, 2, 4, 8, 16, 32 likewise, and that values can go so on. So by dividing those values, we will be having that particular internal clock process with the frequencies of division of that particular values, whichever we have discussed some more, and that particular timer will be given into this particular pulses will be given into this in-bit timer. So this timer can be operated with this kind of control bits. So the timer start, timer stop for using with that particular controls of timer start and stop, and the timer enable. So whenever the particular timer has been given on control, so that particular timer first have to be enabled, and then it have to be started. And the up count and down count can be given as either as an up count or as a down count, depending upon the values whichever we are giving, and that particular timer will be up timer or the down timer, and we will be loading that particular count value as input to this particular timer by this particular load circuit, and the count value will be variable from the 0 to 2 power n minus 1 numbers of counts. So this type of arrangement can be modeled into one particular memory. So for each of the timer, the memory slices will be given, So in that memory slices, these are all the particular parts which are particular memory slices which is being given. So the control variables that we have seen here as the control variables as here, and the status flags. So upon using this control bits, we will be having the status flags also. So the status flags and the preset time will be given, and the counter value can be stored in the next of the memory slice in that particular timer. So these are all the main categories and the main configuration of the hardware timers, whichever are used in the all the microprocessors and all the microcontrollers. These are all the common setup or the common setup which is used in the all the microprocessors and microcontrollers. And in case of software timers, the software timers are going to be used inside the RTOSs or the any of the software which are using the timer as an application. So in this particular type of software timers, we will be given the system ticks as an input. So that particular system tick will be taken as a num ticks. So the numbers of tick values, that is the numbers of clock pulses which has been given, are taken as a num ticks. So the software timer will be loaded with that particular num ticks, and all the control variables will be enabled. So what these software timers will be doing are based upon the control variables and the status flags which we will be giving. So the kind of numticks, after giving those numticks, the control variables are going to control. So the load enable and the up down enable and the timeout interrupt enable are the main control variables which we will be giving. So after that, we will be giving the status flags also. So in the status flags, we will be having the software timer count enable. So whenever this particular count enable is being given, so either up count enable or the down count enable, based upon the application whichever we are using. So after giving this particular enable bits, this particular enable status bit will be enabled. So if the software timer is running, this particular bit will be enabled, and if the software timer is idle, this bit will be enabled. So if that particular counting is finished, so then this SWT finished will be enabled, and the load enable will be the same for the particular bit is loaded and this timer is started, means then this particular SWT load enable will be enabled. So these are all the main memory flags which we are using for the software timers. So for the software timers, the maximum applications of the software timers are going to be used in case of the memory management processes and the process management type of tasks are going to be controlled by this kind of software timers, because we have seen in the previous slides that this particular RTOS controlled hardware timers and the message queues whichever we are using, the watchdog timers we are using, the scheduling events which we are using, and the time slicing between the processors and the context switching between the processors are going to be the applications of this particular software timer. So for this kind of applications, we can be using this software timers for and also for application softwares also. We will be having this kind of timers to be enabled whenever particular communication between two processes are going to be enabled. So when the communication between two processes are enabled, the timer will be started, and if that particular host process doesn't respond, then we will be giving a timeout signal using this kind of software timers. So there we don't need any hardware timers also at all. So that we will be using these software timers for the all kind of softwares whichever we are using for the embedded systems. So that's all about this. We'll be seeing in the next video. Thank you.